Today I'm going to do Proposition 31 from Book 3. So the first step in this proposition is to finish the construction, which is really easy. We can do the construction in one step. So we're going to draw AE, and then we're going to continue this line, AB, all the way up to point F. And so it's going to look like this. And the reason for the first one is postulate 1, which says that if you have two given points, you can just connect the dots. And the reason for the second one is postulate 2, which says that if you have a given line, you can continue that line to a point, which is point F. The second step is, since this is our center, and we have this line BE, and then we also have this line AE, and this line CE. Because of Book 1, Definition 15, we know that any line that comes from the center and touches the outside of a circle are all equal. So that means that BE is going to equal AE, and CE is also going to equal AE. So because we know that these are both isosceles triangles and they have these two sides equal to each other, the angles that are opposite the two sides are going to be equal to each other also. So in the first triangle, that means that angle BAE is going to be equal to angle ABE. And in the second triangle, we're going to have angle CAE equal to angle ACE. And that was because of Book 1, Proposition 5. So since angle BAE equals ABE, these two are equal, and these two angles are equal. So these two angles right here are what make up angle BAC. And since they're equal to these angles, that means that angle BAC is equal to angles ABC and ACB. So the reason for that one is common notion 2, because since these two angles are equal, and they also equal these two angles, when you add these together, you get this full angle, which is BAC. So Proposition 32 says that if you have a triangle, which is going to be ABC, and you extend one of the sides, which is like what we have to point F, then this angle right here, CAF, is going to be equal to ABC plus ACB, which is also what BAC is equal to. So since this is what BAC equals, and it's also what CAF equals, that means that BAC and CAF are equal to each other because of common notion 1. Book 1, Definition 10 says that if you have a straight line, like this one, AC, and you have a straight line that's standing on it, like AF, and these two angles are equal, which we just proved that CAF is equal to BAC. If those angles are equal, then they are right. So that means that angle BAC is a right angle. So Proposition 17 says that if you have a triangle like this one, and these two angles are added together, then they're going to be less than two right angles. And earlier in statement 4, I said that angle BAC, which is a right angle, was made up of these two angles. So if this is one right angle, that means that this angle ABC has to be less than a right angle because it's added with ACB to make one right angle. So we have this quadrilateral, which is ADCB, and so we're going to look at the angle ADC and ABC. Book 3, Proposition 22 says that these two opposite angles added together are going to be equal to two right angles. We already proved that angle ABC is less than one right angle. So if ABC is less than a right angle and it's added with ADC, then that means that ADC needs to be greater than a right angle. So the other thing that we're trying to prove is that this angle right here contained by the straight line AC and this circumference ABC is greater than a right angle. So we already know that this angle here, BAC, is a right angle, and that's part of the whole angle that we're trying to prove, this one here. So if part of the angle is a right angle and this part is also in the angle, that means that the whole angle contained by the straight line AC and the circumference ABC is greater than a right angle. So the reason for that is common notion 5. Common notion 5 says that the whole is greater than the part. So the whole we have is this part right here, and the part we're trying to prove is that it's just greater than a right angle. So the right angle is part of the whole, so that means that this whole is bigger than a right angle. So for the same reason, common notion 5, we're trying to prove that the angle contained by the line AC and the circumference ADC is less than a right angle. So we know that angle CAF is a right angle, that's that one, and we're trying to prove this is less than a right angle. So we know it's less than a right angle because since it's part of what is a right angle, there's no way it can be a right angle or be more than a right angle, so that means it's less than a right angle. So that's the last thing that we had to prove, and so we are done with the proposition.